So, but we are moving on. The nice thing about this section, guys, is this is all review from, Algebra 1, you saw systems of equations. Algebra 2, you saw systems of equations. In geometry, you do systems of equations. This is the 4th time you've seen it, okay? And you've done substitution, elimination. You've done graphing before. This is all review. So chapter 11.1, super easy stuff, okay? So what we're going to be dealing with is systems that look like this, okay? And I call these 2 by 2s because there's 2 variables and 2 equations. So you'll hear me say 2 by 2, okay? And eventually on Monday, we're going to do 3 by 3s, which means 3 variables and 3 equations, okay? Visually, what's happening with these systems are these 3 different scenarios, okay? These 2 are called consistent, where they do intersect. And this one is called inconsistent system, where they don't intersect. Now, I don't make a big deal about that, but the textbook does mention it. So just in case you see it, you have heard that. These are consistent, and this is inconsistent. So one of the consistent ones is where a blue line intersects a red line, and that's at x comma y. Or you might have a red line and a blue line are the exact same line. So what do they have in common? Where do they intersect? They intersect everywhere. Okay, so there would be an infinite amount of solutions. You can use the infinity sign, or you have seen IMS before, which means infinite many solutions. Okay, if you're solving this thing algebraically, whether you're using substitution or elimination, you might get all your variables cancel out and you'll get 0 equals 0. Or you might get, in substitution, you may get like 5 equals 5, or you might get -7 equals -7. Whatever happens, all your variables cancel out and you have a true statement, then you know that you have an infinite many solution answer. Okay? So those are your 2 consistent systems. This guy's inconsistent, and this is where the blue line and your red line do not intersect, and we know those are parallel lines, okay? So this is no solution, the empty set, the null set, whatever you want to say. If you're going through algebraically and all your variables cancel and you get 0 equals 5 or 0 equals -2, or if you're doing substitution, you get 5 equals -7 or something weird where those don't make any sense, all your variables have canceled out and you have something that is silly, that's a false statement, then we know it's a no solution. There's nothing that's going to work that's going to solve it, and that's because you got parallel lines. Okay, so we're going to go through for chapter 11.1, we're going to go through substitution first. And again, I'm going to teach it to you like you've seen it before. Okay, you guys could probably even tell me all the answers and what to do. I'm going to color code this thing. So I got my top one is 2x plus y equals 5, and I hope you're taking notes. And the bottom one is -4x plus 6y equals 12. Well, we want to solve for either this x or y or this x or y. We want to get x equals or y equals so we can use substitution. All right. Now, you have 4 choices, right? But one of them is the easiest way to do it. Does anybody know which one is the easiest to solve for? Does anybody know?
Y.
Yeah, which one, top or bottom?
Top one.
Yeah, this guy right here is the easiest, okay? The reason is it's the easiest is, number one, I only have to do one step. I just subtract that 2x over and I get y equals -2x plus 5. So number one, it only takes one step versus these other ones. I would have to subtract the y over and then divide by 2. That's 2 steps. And I would have fractions. And oh my gosh, I don't want fractions. You don't want fractions. So what we always do is try to find the one that doesn't have a number in front, and it makes it the easiest one, okay? So if you are doing substitution, which sometimes we have to because it says use substitution, then choose the one that has the nice pretty 1 in front or the no number in front, okay? Well, we're going to cut this out and we're going to paste it into the red one. Okay, so you got to use both equations. And I get negative 4x plus 6y, but instead of y, I'm going to put parentheses. Equals 12. And inside that parenthesis, I'm going to put in that negative 2x plus 5. So I'm plugging it in, plug it in. Back in the day, there used to be a thing called commercials that people actually watched, and that was one of the commercials from Glade plugins. Plug it in, plug it in. Oh, man. So we do a little algebra here, right? We go ahead and distribute. So that's negative 4x, and we distribute the 6. 6 times negative 2 we know is negative 12x. 6 times 5 is 30, and that equals 12. From there, combine your like terms, and I would move this 30 over, use subtraction. So 12 minus 30 we know is the negative 18. And then combine these. When they're on the same side, put them together. Negative 4x minus 12x is negative 16x. And then we divide. And guys, sometimes you will run into ones that are fractions, like this one. A lot of times they're nice, pretty numbers, but sometimes they're not. This one reduces. 18 divided by 16. If you need to, throw it in your calc and do math frac. Or reduce by 2 and you get 9/8. Okay. So again, we're trying to get a coordinate point, x comma y. So right now we got 9/8 comma something. So we still need to find the y value. Okay. Well, we can take this x value and we can plug it into the top one, the bottom one, or this new equation that we created. And that's usually the one I would plug in. I would just take this guy and whoop, plug it right in there. Okay, so we've got y equals negative 2x plus 5. If I'm going too fast, let me know. This is where if you want to, you could literally type that in your calculator and it will do all the work for you. Okay, but it's always nice to see that reviewed. So let's take a look. You can multiply and then divide, or I would divide. Negative 9 over 4 and then plus 5. Again, you could throw that in your calculator or get common denominators. Common denominator would be a 4. So I'm going to multiply top and bottom by 4. And then simplify. Negative 9 plus 20 is 11, and then over 4. So final answer is 9/8 comma 11/4. You guys got to see what my math lab is willing to accept. If they want exact values, simplified fractions, then we got to put this one in. Okay. If they want decimals, then you can do 1.125 and what is that? This one, 2 and 0.75, I think, something like that. Okay, you guys see what it'll take. What does it say? Usually it says it in blue. I'm pretty sure they want this. Okay. Any questions, guys, with substitution? I'm going kind of fast, but again, we've seen this. This is the 4th time you've seen somebody teach this. Any questions? Give me a thumb. Where are we at, guys? William's crying. We got thumbs up. We got a chicken. We got 2-pack. He says it's easy. Okay, David says it's easy. All right, I got thumbs. Thumbs are going up. All right, ladies and gentlemen, here we go. The next one. Example 2, we got elimination. All right. So for example 2, I've got 2 equations. First one I got in blue is x plus 2y equals 5, and the second one in red is x plus y equals 3. Okay? When we're setting up elimination, number one, it's nice when all the x's and y's and equal signs and the constants are all stacked up underneath of each other, or like terms. Okay? And what we're trying to do is we want to eliminate either the x's or the y's by getting coefficients, the numbers in front, to be exactly the same, but one's a plus and one's a minus. Okay? Now, to make this a little bit more funner, if funner is a word, I always think of elimination as being terminated. right? And you guys know who the terminator is, right? Who's the terminator? Do you guys know who the terminator is?
Arnold Schwarzenegger.
Arnold Schwarzenegger. You guys know that guy, right? From Austria. Yeah. Used to be a big action star back in the day. Well, I always think elimination, eliminator, terminator, eliminate, terminate. Oh, man. So then Mr. Gotch starts talking like the Terminator. Yeah, how do you do it? What do you want to do? The X's or the Y's? Use your big muscles, Trevor. Not your big muscles on your arms, the ones between your ears. You can do it. How do you do it? How was that? Was that good? Not very good? I'll have to work on it? Okay. How do you do it? Get in the chopper. Do it now if you want to live. How do you solve for X and Y? What do we want to multiply by? Do you want to eliminate the X's? Do you want to eliminate the Y's? I make a little box. What's that?
I said
The
the X's.
X's. Okay, so we're going to eliminate the X's. This is a positive X, that's a positive X, so we want one of them to be negative. Let's go ahead and multiply the red one by -1. Okay, I make little boxes to keep them organized. Okay, and that way I'm going to send this guy through, and everything gets multiplied by 1. So basically stays the same. I get x plus 2y equals 5. The top equation didn't change. But on the bottom, send it through. Everything gets multiplied by a negative. So negative x, -1 times y is negative y, and -1 times 3 is -3. Okay. And now we did all that work so that the x's eliminate. Yeah, very good. So I have 2y minus y is positive y, and 5 minus 3 is 2. So look at how easy that was, right? So we got x comma y. We know our y value is 2. We need to find the x value, okay? It doesn't matter which one you plug it in. You can plug it into the top. You can plug it into the bottom, wherever you want. Where do you guys want to plug it into?
The bottom.
The bottom one. I think that's probably the easiest. Plug it right there. So we got x plus y is 2, and that equals 3. And now we just subtract the 2 over. So we end up with x equals 1. Look how nice and pretty that was. Okay, so the final answer, we get 1 comma 2. Okay, if you look at my substitution, if I was doing substitution, it might be still going through substitution. Okay, this is a technique that you really want to focus on because, number one, I think it's easiest. Number two, when we get into 3 equations with 3 variables, also known as 3x3s, you're going to need to know how to use substitution. Okay, so this is the way to go, I think. All right. All right, all right. I'm hopping. If you got your packet, guys, I'm going to jump over to number 4. Whew. I must be allergic to substitution. Oh my gosh. All right, so when I take a look at number 4, guys, I'll do number 3 in a minute. When I look at 4, I see 2 equations. But I don't like this one. Especially, I want to practice elimination here. If I'm using elimination, I want my x's and y's stacked up. So I'm going to rewrite this guy so it's 2x plus y equals 5. So it's perfect standard form. Okay. And now what do you want to eliminate, x's or y's? What do we need to multiply by? What do you guys think? We got 4x and 2x. You want to do x's again, or you want to do y's? 2y and y. What should we multiply the top and bottom one by? We want the coefficients to be the same. One's a positive, one's a negative. Don't leave. This is the good stuff. Oh, man.
A negative.
Negative what?
-2.
Yeah, let's make this a negative 2 here. So that way, the 2x times -2 will make that -4, okay? The top one we're not going to change. I'm going to put a 1 there. So send it through, nothing changes. Okay? And then send this one through, everything gets multiplied by a -2. So 2x times -2 is -4x. Y times -2 is -2y. And 5 times 2 is -10. Okay? When you guys take the quiz on chapter 11, make sure you have your microphone turned off, or you're going to have we're going to have lots of na-na-nas. All right, when we take a look, the x's cancel. Oh my gosh, the y's also cancel. And that leaves me with nothing. And then 8 minus 10 is -2. Well, that makes no sense. 0 is not equal to -2. That's a false statement. So that's one of those special cases, right? Is that infinite many solutions or no solution when you get a false statement. Infinite many or no solution if it's false. Doesn't make sense.
No solution.
Yeah, this is the empty set, the null set. Okay. What we got going on here, guys, is we got two lines that never intersect. We got parallel lines. All right. No solution on that one. Empty set, null set. Very good. All right, ladies and gentlemen, let's move on to the graphing. We have done graphing many, many times. We've seen this before, so let's get started. So I'm going back to example 3. Okay. First things first, we got y equals -5x minus 2. That is perfect slope-intercept form. Y equals mx plus b. We know our b is -2, and we knew our slope is -5. Think -5 will run. Think rise over run. B, I do that first. Remember, when you have an x and y axis, put a little hump down here. It looks like the letter B. So we put our pencil on the B. We go to -2. It's not hard, you see. Man, we're having fun. Now it's time for rise over run. And then we go, we will graph you. We will graph you. So we got our pencil on the B. And we do our slope. We go down 5, 1, 2, 3, 4, 5, and over to the right 1. That's negative slope. You can also go up and to the left 1. Up 1, 2, 3, 4, 5, and to the left. And then up 1, 2, 3, 4, 5, and to the left. Okay. Really only have to do 2 points, and in my math lab, it's pretty easy to graph these lines. Graph. So I got a nice pretty line there. And now this guy right here, 3x plus y equals 2, that one's in standard form. You could graph it using x and y intercepts, the cover-up method, but I prefer just, hey, let's subtract this guy over. Let's get into y equals mx plus b form. Pick out my b, 2. Pick out my slope, -3. Think -3 over 1. So I go up 2, 1, 2. Put my pencil on the b, and I do my slope. So I go down 1, 2, 3 over 1. Oh, no, that's not going to get there. 1, 2, 3. Oh, no, that's even farther away. So then I want to go the other way. Up 3 to the left, up 3 to the left, up 1, 2, 3 to the left. Ooh, so close. Up 1, 2, 3. Oh, there it is. There it is. Okay, so now we can totally tell whether these guys intersect for sure. From the origin, that's over 2 and up 8. So I got -2, 8. Okay, now if you're graphing, you got to have graph paper, number 1, right? Or have some kind of program that you're working on, like my math lab. Okay, But graphing is one of the worst ways to do it, because if you had the system like in example 1 where we had fractions, well, then you would really have no idea what the answer is. Okay, and that's where you would want to check and figure that out using your graphing calculator. Okay, so I'm just going to walk you through this one quick time here. Okay, so if I'm going to graph these in the calc, I would do negative 5x minus 2. So negative 5x, big minus sign between the two. Okay, so negative 5x, big minus sign 2. And then this guy right here is negative 3x plus 2. Okay, and we've seen this 1,000 times. This is nothing new. I would do zoom 6, zoom standard when I'm graphing these guys. And here's the blue line. And then here's the red line. Here's the red line. There it is. And I can totally tell the intersection is up here. Okay, well, we have seen this before. We've done this 1,000 times. So I'm going to go second, trace, go down to number 5, intersect. First curve, press enter. Second curve, press enter. Guess, press enter, and it jumps to the intersection. And I got negative 2, 8 for that one. Okay, so again, a reminder, you guys can use second, trace. Number 5 is intersect. So second, trace, intersect, and we can find that intersection. Okay, the nice thing is I could use this technique to check all of 1, 2, 3, and 4. I could put those in and then check to make sure I got it right. Okay. All right. Do we have any questions? Last but not least, the applications of this stuff. Movie theater. What's a movie theater? I don't even know. I hope they come back. Oh my gosh. Here we go. Movie theater sells tickets. I got $8 for adults. I got senior citizens pay $6. Okay, must be a rated R movie because no kids are allowed. Says if on a certain night 525 tickets were sold and the theater took in 3,580 in revenue, how many of each type of ticket were sold? So how many of each type? Well, there's 2 types, so I need 2 variables. Okay, I'm going to use X's and Y's. If you want to use A's for adults and S's for senior citizens, that's fine. My A's for me look like 9s and my S's can look like 5s, so it gets me all confused. So I'm going to use X's and Y's. So X's is the number of adult tickets, and then Y is going to be the number of senior citizen tickets. Okay. So I know I'm going to have a 2x2. I'm going to have 2 variables, which I have, X and Y, and now I need 2 equations. Okay, does anybody have one of the equations? Anybody think of one of them? Any ideas? No ideas. Any suggestions for this first equation? Look at the money one. What do you got?
You do x plus y equals 525.
Yeah, there's 525 total tickets sold, right? Total, this is the total equation. Is that you, Trevor? Good job, bud.
Yep.
Take the number of adult tickets and add it to the number of senior citizen tickets, and that would gives me a total of 525. Awesome. Then I see a bunch of dollar signs, right? Okay. Well, then there's a money one. So it's $8 for adults, right? So for every ticket, multiply that by 8 for adult tickets. And then $6 for senior citizens. So take that times 6y. And that would give me a total of 3,580. Okay, so I've got my 2 equations now, my 2 variables, 2 equations, and now this thing's ready to go. Okay, if you got 3 or 4 different ways now, if you want to do this by hand, You could graph it, substitution elimination. If you want to try to put this in your graphing calculator and find the intersection, hey, have at it, okay? For me, I think elimination would be the easiest, okay? So I would probably eliminate, I don't know, the y's. This is 6y. I'm going to multiply this guy by a -6. And I'm going to leave this one alone, okay? So I send this guy through. No. This guy goes right here. That's -6x, -6y, and -6 times 525. I got 3,150. Okay. Now, if you make one silly mistake, it's going to botch the whole thing. So if you didn't make this a negative, oh boy, it's going to be all wrong. So make sure you don't make silly mistakes. We did all that work, so these guys eliminate. 8x minus 6x is 2x. And 3,580 minus 3,150 gives me that 430. From there, I can go ahead and divide, and I get x is 215 adult ticks. Okay, so we got the x value, and then y is pretty easy to find, right? If I want to find the y value, I'd probably plug it into this one here. Okay, so if I want y, I would take 525 and subtract the 215. So that would give me 310 senior citizen tickets. Okay, so there we go. We got a application type problem that you would see. Okay. All right, ladies and gentlemen, if you still have questions and trying to get ready for this quest tomorrow, please stick on and ask some questions. If not, you guys are free to go. Have a great day. Quest tomorrow. That's the only thing we're doing.